When it comes to Python, it is robust and very powerful programming language. It is widely used by different types of engineers for different purposes. Some of the engineers which use Python as programming language are nothing but data engineers, software engineers or application engineers, DevOps engineers, system or network administrators or engineers. All these engineers might have to perform repetitive tasks on top of underlying operating systems. Most of the applications will be deployed on Linux, and hence most of the times these engineers have to work on top of Linux operating system. In this sectional module, we'll actually get an overview of automation using Python on Linux so that these repetitive tasks are automated using Python as programming language. First, we'll start with validating which version of Python we have, and also we'll see whether important Python modules such as pip are actually installed on Linux or not. We'll be using Ubuntu for the demonstrations. Once Python is validated and also important modules are installed, then we'll actually go to the details related to setting up and validating Jupyter Lab on Ubuntu. The reason why we'll be using Jupyter Lab is to create notebooks over a period of time to automate our repetitive tasks as a team. Once we set up Jupyter Lab, we'll actually take care of creating folder for our notebooks. Then we'll actually explore modules such as getpass, OS, glob, subprocess, etc. These four are some of the important modules in Python which facilitate us to interact with underlying operating system. We typically use these against Linux as operating system. Also in that process, we'll understand how to run Linux shell commands from Jupyter notebooks itself. There are multiple ways to actually run Linux shell commands from Jupyter. We'll explore all those options. We'll also take care of setting up datasets that are relevant to explore modules such as glob, subprocess, etc. Once we go through these Python modules, we'll actually perform few tasks to understand the power of automation using Python on Linux. Make sure you go through those tasks and understand the power of Python, which will facilitate you to automate repetitive tasks which you perform on regular basis in your organization. As part of this lecture, let's go to the details related to validating Python on Ubuntu operating system. When we set up machines using Ubuntu, we'll be having Python by default. First, let's see which version of Python we have. Then we'll also see whether Python related modules such as Python venv, Python pip, etc. are set up or not. To validate versions of Python on Ubuntu, you just say Python and hit tab twice. To see the commands which start with Python, you can ignore the commands which have exe extension. These are related to Windows, not related to Ubuntu, and hence we don't need to worry too much about these two commands. However, out of these four commands, the ones with config are not relevant at this time. The only ones which are relevant are nothing but Python 3 and Python 3.8. Don't think that we have two versions of Python in this. We have only one. It is nothing but Python 3.8. Python 3 is nothing but a soft link to Python 3.8 or alias to Python 3.8. You can actually say Python 3, hit enter. The version of Python is nothing but 3.8.10. Now let me exit from here. Instead of saying Python 3, let me say Python 3.8. Then hit enter to run it. You can see the details here. It is same as what we have seen earlier, which means Python 3 is nothing but alias or soft link to Python 3.8. So we have only one version of Python, which is nothing but Python 3.8. In some cases, you might end up having multiple versions of Python in case if you set up additional versions of Python. That being said, along with Python, it is also important to have Python venv and also Python pip. To validate whether we have Python venv or not, we should be able to say Python 3, then -m venv. Then you should be able to specify the virtual environment name. Let me say testing -venv. Let me hit enter. It seems to be set up. That's why it have ran successfully. When we run this command, it will actually create a folder with this name. You can validate by saying ls-ltr. You can see testing -venv. Now you should be able to say source testing, then -venv, then bin, then activate, hit enter. It will activate that virtual environment. You can validate whether the virtual environment is created successfully or not by using this approach. To deactivate, you just have to say deactivate. Now it is deactivated. If you want, you can even clean up by saying rm-rf testing -venv. It will take care of deleting the folder that is created for the virtual environment. As of now, the venv related to Python is already there. If it is not available, then you have to use sudo apt update. It will take care of updating the apt lists. Once the apt lists are updated, you should be able to use apt install command to install Python environment or venv module. Let's wait until apt update is run, then we will take it further. Now apt update is successful. We should be able to say sudo apt install, then Python 3 -env. That is the module which is supposed to be installed. I think it is venv, not env. Let me add v here. You see it is saying Python 3-venv is already in the newest version, which means it is already set up. I might have ran it earlier as part of some other demo. That being said, in case if Python 3-m-venv command which we have seen earlier is not run, then make sure you run apt update and then run apt install to install Python 3-venv. Then run this command. It will take care of creating the virtual environment for you. On top of Python venv, you should also have Python pip. To see whether you have Python pip installed or not, you should be able to say Python 3-m pip, then install, let me say config parser, just to validate whether pip is there or not. Let's see what it says. If pip is already there, it will actually take care of installing config parser here. You can see it is successful, which means pip is already installed. In case if the pip install command fail, make sure to install Python 3-pip. The way you can install Python 3-pip is like this. Sudo apt install, then Python 3-pip. In my case, I have already installed. That's why it will just say pip is already at the newest version. That being said, on this machine, we not only have Python 3.8, we also have important Python-based modules such as Python 3-venv and Python 3-pip. Make sure you have all these. As we have validated Python, now let's go ahead and set up Jupyter so that we can explore the integration of Linux with Python using Jupyter notebooks. It is optional to set up Jupyter, but having Jupyter will streamline your learning process. I would highly recommend to follow the next lecture and set up Jupyter before getting into the details about integrating Linux with Python. As we have successfully validated whether we have Python along with pip as well as venv in the previous lecture, now it is time for us to set up Jupyter Lab using pip. When it comes to using pip and setting up tools like Jupyter Lab, either you can set up globally or you can set up at user level. In this case, I'm going to set up globally. To set up globally, you just have to say Python 3, then -m pip, then install. In this case, we are actually setting up Jupyter Lab. Just hit enter. After typing this, it will take care of installing all the dependencies related to Jupyter Lab. Once Jupyter Lab is installed, then we should be able to validate by running command called as Jupyter space lab. Let's wait until it is completely run, then we will take it further. The command ran successfully, which means Jupyter Lab is installed on this machine. To launch the Jupyter Lab environment, you just have to say Jupyter space lab, then hit enter. It will take care of launching the environment for you. However, it is failing. It is actually failing with this error. Import error, cannot import name soft Unicode from markup safe. Let's copy this into the buffer. Let's open our browser. Let's Google around to see if there is a solution for this. Let me paste the error here. Many times it fails because of the compatibility between the operating system Python version and the latest Jupyter version. Now let's click on this. Let's scroll down here. There seems to be a solution here. Let's copy this. Let's go here. Let's paste. Hit enter. It is complaining because of this. I have to just delete this. We just have to upgrade AWS SAM CLI. Now SAM CLI is being upgraded or being downloaded. I think it was not there earlier. It will take care of installing AWS SAM CLI. In that process, it might upgrade some of the modules which are important for Jupyter Lab. You can see there is something called as markup safe. It have uninstalled it and it have even installed it. Now let's try running Jupyter Lab here. Now Jupyter Lab is started. We should be able to access by using this URL. Either you can use localhost or 127.0.0.1. Either of them will work. Let me copy this. Let me go to the browser. Let me paste here. After pasting, once you hit enter, it will actually launch the Jupyter based environment as part of your browser. This is how you should be able to set up Jupyter Lab using pip. Then you should be able to access without any issues. You can also validate by clicking on Python 3 kernel. Then you can actually say print hello world. Then run it. If everything is set up properly, you should be able to see the hello world message here. By default, the Jupyter notebooks will be created as untitled. If you want, you can actually change it, or you can even save with the same name. If you wanted to change the name, you just have to right click, then say rename notebook. Then you should be able to change the name for the notebook. In this case, let's say getting started. Now the notebook is renamed as getting started. You should be able to see this notebook in the sidebar as well. You can see the getting started notebook here. Now if you wanted to delete, you can just right click and you should be able to delete by clicking on delete. This is how you should be able to not only launch Jupyter but also get started with it. That being said, as we are ready with the environment, now let's use this environment to explore the integration between Python and Linux using appropriate modules. In the process of understanding the integration between Python and Linux, we'll be creating quite a few notebooks to explore Python modules and also to perform quite a few tasks. Let's make sure we organize all those notebooks in one folder. Creating a new folder using Jupyter Lab is very straightforward. You just have to open the sidebar and then click on this to create new folder. Let me create a new folder by name Python and Linux integration. In this case, this folder will be created in the home directory of the user because we have launched Jupyter Lab from the home directory of the user. The home directory of the user is nothing but /home/my username using which I have logged in into that Linux-based machine. In my case, it is nothing but home d-gadiraju. Depending upon which folder you actually started Jupyter Lab, by default, you will end up in that folder. These are the subfolders in my home folder. That's why you are seeing all these. Now I have added a new folder called as Python and Linux integration. We can actually open another session here. Let me open another Windows PowerShell, then use WSL to get into the Linux. Let me go to the home folder. Now you can see there is a new folder by name Python and Linux integration. This is how you should be able to validate, and also you can actually go to the Jupyter based environment itself. Click on this to collapse. If you scroll down, there is a terminal also here. You can click on the terminal. You should be able to see the Linux CLI here as well. Whatever you are seeing here is being shown here. You can also validate by saying ls-ltr. You can see the Python and Linux integration folder. So as part of this folder, we'll be creating the notebooks. To create notebooks in that folder, you just have to get into the folder in the sidebar, and then you should be able to click on plus to launch the launcher. Then you should be able to click on this to create the notebook in this folder. You'll be seeing those details as we go along. As of now, the required folder is created and also validated. Now it is time for us to explore all the important Python modules related to Linux integration. We'll also perform quite a few tasks by using several notebooks. As part of this lecture, let's go to the details related to getpass. For that, I'll be creating a new notebook. Using launcher, I have launched the new notebook. As I'm in Python and Linux integration folder, the notebook is created in this folder. Let me rename this Understanding getpass. That is the notebook name. Now you can import getpass like this. It is available out of the box in Python. You don't need to install any additional libraries for this. Once you import, you can actually say getpass, then dot, then hit tab. You should be able to see different functions and modules that are available under getpass. The most common one which I typically use under getpass is nothing but get user. You see there is a function called as getUser. Also there are functions such as getPass, so and so forth. I don't use getPass that often. I only use getUser, and also getPass have OS module. I'm not 100% sure about that module. The only function which I typically use is nothing but getUser. Now let me add question mark at the end to see the help on getUser. It actually gets the username from the environment or password database. In this case, we can actually say getpass.getUser, run it. You can see the user that is used to log into the system. It is nothing but this one. Now you should be able to assign it to a variable. Let's say username equal to getpass.getUser, run it. You can validate the content of username by saying username. So whatever we have seen here is now assigned to variable by name username. You can check the type of username by saying type. Type is a special function in Python which gives the data type of a variable. In this case, username is nothing but a variable which contain the username that is used to login. Type of the username is nothing but string. You should be able to see the details here. This is how you can actually get started with a very basic module called as getpass, which can be used to actually get the logged in user details from any operating system. In any of those scenarios where you have to use the logged in user details, you should be able to use this approach. Just use getpass module, invoke getuser function, then get the logged in user details. You should be able to leverage the way you want. As we have gone through the details related to getpass, now let's explore another important module, which is nothing but OS. As part of this lecture, let's understand how to run Linux commands using Jupyter-based environment. There are multiple ways to run Linux commands. One, you can actually launch the terminal and you should be able to run Linux commands. To launch the terminal and run Linux commands, either you can go to the launcher. Once you are in the launcher, you can scroll down here. You can see terminal. You should be able to launch the terminal from here, or you can also launch the terminal from file menu. File, new, and then terminal. It will launch the terminal. Once the terminal is launched, you should be able to run commands of your choice. Let's say you would like to see all the files and folders in the folder that is displayed here. You should be able to use ls-ltr command like this, and you should be able to see the output. Also, you can run any valid Linux command such as pwd to get the present working directory, so on and so forth. This is one of the ways to actually run the Linux-based commands. However, sometimes we might want to run Linux commands within the notebooks itself. Let us also explore those details. When you actually add cells by using this plus, the default type of the cells is nothing but code. You can see here. As and when I add cell, you can see the type of it. It is nothing but code. You can also select this drop down. There are also other types. They are nothing but markdown, raw, etc. But the default type is nothing but code. What code mean here? Jupyter is based on Python. As it is based on Python, it will actually interpret the code using the Python. There are also other types of kernels. If you are using non-Python kernel, it will try to interpret the code using that programming language. As of now, we have only Python-based kernels, and hence, when we talk about code, it is nothing but Python itself. Now, if you say print hello world, as this is valid Python code, it will work without any issue. However, if you try to use other programming language syntax, it will not work unless you change the kernel. When it comes to the Linux, you should be able to use something called as magic. There are multiple ways to run Linux commands. In the earlier versions of Jupyter, you have to use magics only. Without magics, it will not work. When it comes to Linux commands, the magics can be passed in multiple ways. One of them is nothing but %sh. Then you should be able to say ls-ltr, run it. You can see the output here. This is one of the ways where you can run shell commands within these Python-based kernels. You can also use exclamation mark like this and then say ls-ltr. Even this one will work. In the latest versions of Jupyter, you don't even need to use magics to run shell commands. For other programming languages, you have to change the kernel. If you are using Python-based kernels, even if you don't use magics, most of the shell commands will work without any issues. Some commands might not work, but most of the commands will work. In this case, I am not adding any magic. I am just making sure that the cell is of type code. You can see here it is of type code. Now I can run this. Even it have returned same output. This is how you should be able to use Jupyter notebooks to actually run the Linux commands. On top of these things, we have also seen the details related to going to the terminal and running the Linux commands from there. As part of this lecture, let's get an overview of OS module. OS is a very important module. It will facilitate us to interact with the underlying operating system in many ways. The way you can import OS is like this. You just have to say import OS, then the OS module will be imported. It also comes out of the box with Python as programming language. You don't need to install anything extra to use OS. Now, to review what all OS contain, you can actually say OS, then dot and hit tab. You can see the list of functions that are available here. We have functions such as about, access, chdar, chmod, ch1, etc. If you are familiar about Linux commands, you should be able to relate to these functions easily. On top of these things, we also have environ. It is of type attribute or instance. You can see environ, which is of type instance. It is not of type function. It will actually expose several other functions to interact with environment variables. Now let's scroll down further to review all different instances and functions that are available in OS. Yeah, the OS have quite a few functions as well as instances. Instead of going through all those details at this juncture, as part of overview of OS module, let's understand how to use functions such as environ.get to get values related to the environment variables. Before going through the details, let's run this command. It will return all the environment variables that are controlling this session. You can see the details related to shell here and also the host name here, also present working directory, the login name, also the username. Let me scroll down here. You can see the user details using environment variable called as user. Now, as part of the OS, we have something called as environ. It is of type os._environ class. You can actually validate by saying type os.environ. It will give us the details about this attribute that is there as part of OS. Now you should be able to even see the contents of os.environ. For that, I have created a new cell, then copy pasted this os.environ. Let me run it. You can see the contents of environ. When it comes to environ, it is dict type object. That's why it is in curly braces. It contains all key and values related to environment variables. Now let's scroll down here. Let us add a new cell and then say os.environ.hit tab. You should be able to see all the functions that are available on this object. You can use get to get the value by passing the key. You can also use keys to get all the keys. You can also get all the key value pairs using items, so on and so forth. As part of this overview lecture, let's explore get function in detail. Now let me say get here, then question mark. We should be able to see the help. There is a typo in function name. Let me fix the typo. Now let me run it. You can see the details with respect to the get function. You just have to pass the environment variable name. It will return the corresponding value. Already we have environment variables with the names user, name, etc. In this case, I'm actually using user as the key and trying to get the corresponding value. You can see the corresponding value here. You should be able to use get like this and assign it to a variable as well. Whatever value that is returned by this function will be assigned to this. The type is of type string only. It always returns string type. Let's run this. Now username is of type string. You can actually say type of username to get the type of username variable here. You can confirm that it is of type string. In the similar manner, you can try getting the value related to the name variable. Name holds the host name into which we have logged in. As of now, the host into which I have logged in is nothing but this one. This is how you should be able to get the values for the environment variables by using get function that is available on top of os.environ. We just need to pass the environment variable name. As long as you have fair understanding about environment variables in underlying operating systems, you should be able to use this module and play with those environment variables. That being said, this is just overview of OS module. We have seen only one basic example. We'll be seeing quite a few examples in the subsequent lectures in this section as well as subsequent sections. Make sure you are really comfortable with OS to interact with underlying operating system. In the process of getting started with Python and Linux integration, so far we have gone through the details related to getpass and OS modules. Before getting into other modules such as glob, let's make sure we have data setup in this folder in which we are coming up with the notebooks. You can actually run this pwd command to confirm which folder we are in. You can see that we are in Python and Linux integration. As of now, this folder only contains these notebooks. There is also a folder by name data. Let me actually clean up that data folder as well. To clean up the data folder, I can actually say rm-rf then data. It will try to look for data folder in this location which is returned by pwd. It will take care of deleting that folder if it exists. As the folder exists, it will be deleted. Now let me refresh this. Data folder is gone. I have already created a backup for data folder in the form of compressed tarball. The backup is under /tmp folder. Let's run this command to see if we have data.tgz, which is nothing but compressed tarball for data folder. You can see here. If you want, you can also review the content of this compressed tarball using tar-tvf or tzf. You should be able to get the details about the compressed tarball. I'll not be running that command. I'll just copy this to the current directory. For that, I should be able to use this cp command. It will take care of copying this compressed tarball into the current folder. Dot represents current directory or present working directory. Let me run it. It will take some time and compressed tarball will be copied. Now it is copied. Once it is copied, we should be able to use this command to actually uncompress the tarball. In this case, I can actually remove /tmp here. Data.tgz is already in this folder and hence there is no point in adding /tmp here. I can actually say -xzf. However, if you do not have exclamation mark here, it will not work. By default, it will look for Python code. For some standard Linux commands, it will work, but for some other commands, it will not work. I have removed exclamation mark or magic and you can see that it is not working, it is failing. As soon as I add exclamation mark, it will be interpreted as shell command only instead of Python based code and hence it will work without any issues. It will just take a moment to actually uncompress and untar this tarball into data folder. Now it is run. We should be able to refresh. You can see the data folder here. As data folder is created, I would like to clean up data.tgz in this current working directory, and hence I should be able to use rm command like this. It will take care of deleting the file. Now the compressed tarball is gone. You can see it is automatically refreshed. You can validate whether data folder have files or not by using the simple find command. In this case, I'm using find on top of retail_db. Now let me run this. You can actually see the files under retail_db. As we have required datasets here, now let's go ahead and explore glob a little bit at a higher level. We'll also see few examples using glob in subsequent lectures in this section or in lectures in the subsequent sections. That being said, make sure you have the datasets so that you can explore modules such as glob. Datasets will also be handy for modules such as subprocess, which I'll be covering at a higher level in this module and a lot more in detail as part of the subsequent modules. As part of the sectional module, we are going through the details related to Python and Linux integration. In that process, so far we have seen modules such as OS, getpass, etc. Now it is time for us to explore another important module called as glob. When it comes to glob, we have already seen in the Linux as well. We have used these patterns. These patterns are nothing but glob patterns. When it comes to Python glob, it is a utility which actually facilitates us to search for files and folders based upon certain glob patterns. Now star means anything. Question mark means any one character. Let's import glob here. Then you can review the output of this command using data from current folder. I'm actually checking what all we have under this path. Under data, we have subfolder called as nyc_all, which have another subfolder called as nyc_data. We can see all the files in that folder. Now let's run this to get all the files with .txt.gz extension. You can see all the files here. In case if you want to get all those files with nyc_200 prefix, you should be able to say nyc_200 either star or question mark .txt.gz. As we have only one character after 200, whether you use question mark or star, it will work. Now let's try to get all those files which belong to 1900 years. We have only 3 files. Using this approach, we should be able to get all those files which ends with 19th century. Let's run this. There are only 3 such files. You can see the 3 file details here. In this case, I have used question mark, which means any one character after 19, then another character after that one. You can see there are only 3 such files. Question mark means any one character, star means anything. That being said, these are some of the glob patterns. Now let's look at the help related to glob. Glob is a module. It have 3 functions. One is escape, second one is glob, third one is iglob. There are quite a few other stuff also, but these are the 3 functions which are available. Predominantly we use glob to pass the path, and also we can specify whether we want to go through all the directories in that path recursively by saying recursive equal to true. We predominantly use this function which actually return list of paths matching a path name pattern. Also, there is something called as iglob. I haven't used it in the past. If you want, you can explore. When it comes to the definition of it, it says return an iterator which yields the paths matching a path name pattern. So the difference is yields. So you need to understand the concept of yield Python, then it will start making sense. For now, let's focus on glob itself. Now let me scroll down here. We can actually see the help related to glob by saying glob.glob question mark like this, or even you can use help on top of glob.glob, and you should be able to see the details about this function. Let's explore how glob can be used. Typically we pass 1 or 2 arguments. If we pass only 1 argument, we need to pass the path. It will actually give us the details about that path. In this case, I have given the path of retail_db. If I run it, it have returned a list. The list contain only one element. The element is related to this path which is passed to glob. You can also use star like this and see what it returns. You can see that it have returned all the subfolders and files in this location. These are nothing but names of the files and folders in retail_db. If you want to go through all the files and folders recursively, then you have to use recursive equal to true, and also you have to specify double star like this, then only it will work. Now let's run this. You can see all the files and folder names in retail_db location. It have gone through all the folders that are there recursively, and it is able to get all the file names as well as folder names in those subfolders as well. Now we can confirm if each of these entities are related to files and folders using OS module. Let's import OS module. It has something called as path. path is nothing but module. It have a function called as isFile. IsFile, we can confirm whether given path is related to a file or folder. You can get the help on isFile using this approach. It says test whether a path is a regular file. Now path can be passed as a string to isFile. In this case, I'm actually using the output of this, which is nothing but this one, which we have seen earlier. I would like to check whether each of these entities are file or folder. We should be able to use os.path.isFile, and we should be able to pass each of those entities in for loop like this. It will actually return true or false. You can see here. When it comes to the first one, which is nothing but data return_db, it is a folder and hence it is returning false here. We can improvise on top of this by using this piece of code. In this case, we are actually printing the file name and then we are actually saying whether it is a file or not a file. I have a ternary operator. In this case, if this returns true, then we are saying a file. You can see here. If this returns false, then it will go to the else part. Then it will return not a file. Based upon whether a given entity is related to a file or not a file, you will see appropriate string. Now let's run this. You can actually check whether each one is a file or not a file. So in this case, it is not a file, it is a folder. Even this is not a file, it is a folder. Whereas part-50 under orders is a file. And you can see the information here. It is nothing but a file. Now when it comes to the glob, we can also pass patterns like this. In this case, I'm actually checking for all files which starts with part or folders which start with part within all subfolders in retail_db. I'm saying data retail db then star, which means any folder in that location. Within those subfolders, the files or folders which start with part. Now let's run this to see if this works or not. You can see it is only returning the ones which have part in it within each and every subfolder of retail_db. This is how you should be able to leverage patterns, and you should be able to search for files and folders using glob, leveraging Python as programming language. It is another way of interacting with OS level file system, and hence I am actually covering it as part of Python and Linux integration. This is one of the important aspect which any developer or DevOps engineer or system administrator should be familiar with. Many times we might have to deal with the files in programmatic way. Using Python, using glob, we should be able to deal with files easily. We typically combine glob with other modules. For example, to see if each and every entity is a file or not, we have used OS module. Like that, we should be able to leverage other modules as well. As part of integration between Python and Linux, in this lecture, let's go through a very important Python module called as subprocess. First, let's import subprocess. Let's get help on subprocess. You can actually go to the description related to this module to understand what it is all about. Even though it is a little bit cryptic, it actually means that you should be able to run underlying operating system commands and you should be able to process the output as well as written codes. Let's go to the details so that you understand what I'm talking about. When commands generate output, we should be able to capture that output, process further using subprocess module. Subprocess is a big module. Instead of covering all the details with respect to subprocess, I'll be covering details related to two important functions called as check_output and check_call. Let's clear the output instead of scrolling down. Now let's run this to see if there is a file by name subprocess_demo in the current folder. There are no entities with subprocess_demo. That's why it haven't returned anything. One of the important functions with respect to subprocess is nothing but check_call. You can issue commands like this. You should be able to capture the error code. Error codes are nothing but 0 or 1. 0 means success. 1 means there is some issue with respect to the running the command. Let's check the help on check_call. You can see the details here. You can pass the command with arguments. When they say command, they are talking about Linux command. It will wait until the command is complete. Once the command is complete, if the exit code was 0, then return, which means if the command is successful, then it will return 0. Otherwise, it will raise called process error exception. It will just say the command is returning error code 1. Then you should be able to troubleshoot further. This is one of the ways where you can use check_call to pass underlying operating system commands. In this case, we are trying to pass ls-l. Instead of specifying ls-l, we are converting ls-l to list and we are passing the list here. The original command is nothing but ls space -l, which is converted to list like this. The first element contain ls, second element contain -l. It will actually concatenate these things and build a command and then it will run. While concatenating these elements, it will use space as delimiter between them. That being said, we can also use shell equal to true like this. Then we should be able to pass the commands directly. You can actually say ls-l shell equal to true, it will work. You don't need to pass the command as list. Instead, you can pass the command as string. You can see an example here. We are using touch space subprocess underscore demo. As we are not passing the command as list, we have to say shell equal to true, then only it will work. Now let me run this. You can see that the written code is 0, which means it is successful. You can see the file as well here. Now you should be able to delete this file using the same approach again. In this case, I'm actually saying rm-f subprocess underscore demo so that the file is deleted. You can also convert this to list and you should be able to pass the list without shell equal to true as well. If you want, all you need to do is you enclose it as part of the square brackets like this. Let me close the square bracket. If you want to pass it as list, you have to remove shell equal to true. Let me remove this. Now we should be able to say single quote, then comma. Even -f should be within single quotes or double quotes. Same applies with subprocess underscore demo. Now we have converted the command rm space -f space subprocess underscore demo into list with the 3 elements rm-f, then subprocess underscore demo. Now we should be able to run it. You can see the error code here. It is nothing but 0, which means it is successful. Now if I run it, it will say no such file or directory because the file is already deleted. You can also use commands like this to find the files. This is a Linux command. However, we should be able to use glob to get the details about the files. You can see the details here. In this case, we are actually importing glob and then we are actually getting all the files from the data folder. By saying data /* recursive equal to true, you can actually review the first 10 entries. Now you should be able to see only those files with gz extension using this approach. So I have used glob and then try to process data to get all those files with gz extension. You can run this. You can see the output. The output contain only those files which have gz as extension. Instead of using glob, we can also use find command like this. In this case, I'm just saying find data -name star.gz. As this is passed as string, we need to say shell equal to true. So instead of using glob, I'm directly using find command which is available on top of Linux operating system. Now if you run it, it will actually generate the output. When it comes to the type of this output, it is of type bytes. You can see there's a B at the beginning and then the whole content is within the single quotes, which means it is of type bytes. You can also say type of this one, it will return bytes. If it is bytes, you should be able to convert it to string using a decode like this. So on top of this piece of code, I am using decode function, which will actually convert this output to string type. Once the output is converted to string type, we should be able to use split lines to split the data using new line character as the delimiter. Then it will actually return a list. The list will contain all those names of the files with gz extension. You can check the output here. Each and every entry ends with gz. Either you can use this approach leveraging check output under subprocess to get the output of a given command and process further to get whatever we are looking for, or we can also use Python glob module to recursively go through the data folder and then filter for those entities which have gz as extension. Either of the approach will work depending upon your preference. You can choose whatever is convenient to you. Glob is platform agnostic. You should be able to run it on Windows or Linux. It will work. Whereas the find command which is used as part of subprocess.checkoutput is Linux specific. If you try to use the same command on Windows, it will not work in the same manner. In many cases, it might even fail saying no such command found. That being said, make sure you understand even these subtle differences while making choice between which module you should use for a given problem statement. As part of this lecture, let's go through the details about sorting all files in Linux file system using Python as programming language. The equivalent command for that in Linux is nothing but this one. This will find for all the files in data folder. Then it will actually execute du-sb command on top of all the files in that folder. Then it will actually sort the output numerically. You will see the largest file at the end, smallest file at the top. Let's run this to see the output. We should be able to see the details about the files here. Let's only see last few files. For that, I should be able to use tail command after sorting. So let me say tail, then -5, which will give us the last 5 files. You can review the details related to largest 5 files here. That being said, we should be able to use this command as part of subprocess.check output, and we should be able to get the details of the file sorted by the size. However, instead of using it, we should be able to use OS module along with the glob to get similar output. This logic actually gives us all the files and folders under data folder, because we are saying recursive equal to true with star star. Then we have to check whether each and every entry is a file or folder. Only when it is file, we wanted to get the size. Here we are checking whether each and every entry is file or not. If it is a file, we are actually getting the size of the file and assigning it to file size. Once we get the file size, we are actually appending both name and file size as tuple to list. The list is initialized here. It's an empty list. By the end of it, it will actually get all the names of the files along with the sizes. You can actually run these 2 cells. It will take care of creating file sizes. When it comes to the actual logic, this is where we are actually filtering for file type. When we say -type F, it is actually getting only those entities which are files. All the folders are discarded. Once we get all the file names using this logic, then we are actually passing the output to du-sb to get the size. Whereas here we are using this approach to get the size of the file. As this is run, file sizes will have list of tuples. Each tuple will contain the name of the file and also the size of the file. This is where we are actually placing the size of the file. It is the second element within each tuple. Now let's run this. It will return last few entries. You can see the name and also you can see the size. However, data is not sorted. You can use function called as sorted, and you can specify on what criteria you want to sort the data. In this case, we would like to sort the data by size. For that purpose, we have to use keyword argument called as key as part of sorted. Then we have to specify the logic using lambda function like this. In this case, file is of type tuple. We are considering the second element in the tuple as the sorting key. Now, if you run this, it will actually sort the data in ascending order by size. You can review the output here. The output is of type list. You can see sorted have returned a list. To get last 5 elements from this list which contain largest 5 files, we should be able to specify something like this. -5 : then close the square brackets, run it. You can see the details about largest 5 files. You can compare this with the other 5 entries which you have seen at the beginning. We have 2012, 2013, then order items file, then nyc data.tar.gz, then .git objects pack. You can see the similar output here, but there are some differences. The differences are due to the hidden folder .git. When it comes to the find command, it have actually considered the hidden folder. When it comes to glob, it haven't considered the hidden folder. That's why we see the difference as part of the output. This is how we should be able to automate tasks based on the file metadata using Python as programming language. Whatever find command we have seen here is available only on Linux or Unix. However, to achieve similar functionality on Windows, we should be able to use modules such as glob and OS, and we should be able to get similar functionality. This is very powerful. Make sure you are comfortable so that you gain enough skills to take care of automating the repetitive tasks on top of Linux file system or even Windows file system. Many times as engineers, when we support applications on top of Linux operating system, we might have to perform several long-running tasks. One of the ways to improve the performance of long-running tasks is to leverage the multiprocessing capability on underlying operating system. Python have a module called as multiprocessing. We'll go to the details about using multiprocessing to take care of parallelizing the long-running tasks in this lecture as well as subsequent few lectures. First, let's try to uncompress all the compressed files. Let's also compute the time to take care of uncompressing all the compressed files. Then we'll see whether using multiprocessing will improve the performance or not. As of now, there are quite a few compressed files. We should be able to run this command to get all the compressed files. For some reason, it is complaining saying unexpected EOF while looking for matching blah blah blah. There is no double quote here. That's why it is complaining. Now it should work. You can see that there are quite a few compressed files. I would like to uncompress all these files. I'll be using Python as programming language for uncompressing all the files. To get compressed files, either we can pass the same command what we have seen earlier as part of check output, which is available on top of subprocess. Then the output will be written in the bytes. We should be able to decode to string using decode. Once the output is converted to string, we should be able to use split lines to get all the compressed file names. Let's run this. Now let's run this. You can see all the compressed file list here. You can also use glob. This will take care of iterating through all the files, and then we are checking for those files which ends with gz. You can see all the file names with gz extension. These are nothing but the compressed files. As we are trying to uncompress the files on Linux file system, either of the approach will work to get the compressed file names. Once we get the compressed file names, we should be able to uncompress using logic like this. In this case, I'm actually processing one file at a time. I'm passing the file name to this os.system along with the gunzip command. It will take care of uncompressing the file. You can also use subprocess.checkout. In this case, either we can use os.system or subprocess.checkout. Now let's import os here because we are using os.system to run this command on each and every file to uncompress. Let's run this. Now it is executed. Because of this Jupyter cell magic, we should be able to see the execution time as well. You can review the details here. It took 33 seconds to uncompress all the files. When it comes to getting the list of compressed files, we can use either of the approach. Once we get the compressed file list, we should be able to leverage this approach to uncompress all the files in sequence. As the files are uncompressed in sequence, it took 33 seconds. If the files are too many or if the file sizes are large, then it might take a considerable longer amount of time. One of the ways to streamline the process is to actually issue these gunzip commands on different files leveraging multiprocessing. We'll go through those details as part of the subsequent lectures. First, we'll get an overview of multiprocessing. Then we'll see how to streamline the performance of this task by using multiprocessing. As part of this lecture, let's go to the details related to overview of Python multiprocessing. Python multiprocessing can be used to actually improve the performance leveraging multiple processors that comes as part of our systems. That being said, let's import time here. Also, let me run a command called as lscpu. Let's say lscpu. It will give us the details about the CPU. This machine on which we are trying to explore multiprocessing have 4 CPUs. From where this 4 came from, it is nothing but product of sockets, cores per socket and threads per core. 1 multiplied by 2 is nothing but 4. That being said, as we have 4 CPUs, we should be able to use at least 4 threads in parallel. Depending on the nature of the workloads, it can go up to 16 as well. As of now, we have 4 CPUs. We will be using 4 threads only because we need some threads for operating system and few other things. We will not go above 4 threads while exploring multiprocessing. That being said, now let me scroll down. Let's explore this function called as sleep that is available on top of time. Time is nothing but Python-based module. This will actually take care of sleeping for 2 seconds. You can see that it didn't return immediately. It have returned after 2 seconds. Now I am importing multiprocessing as MP. MP is nothing but alias for multiprocessing. Now I am creating a pool. Pool is nothing but a class in multiprocessing module. We should be able to pass a number of processors we want to use in parallel. Make sure it is somewhere between 4 and 16. Don't go above 16 at any point in time. Let's run this. Now the pool is created. The reason why I have demonstrated using sleep is I'll be using multiprocessing module to invoke sleep function. When it comes to multiprocessing, there are functions such as map, star map, etc. We should be able to invoke existing functions without any issues to run those functions in parallel. Now let's also explore another module called as random. Let me run this. It will import random module. It have a function called as sample. You should be able to specify the population and number of items you want to have in the sample. In this case, the population is nothing but range between 1 to 5. We are trying to get a sample of 4 items with elements between 1 to 5. 1 to 5 means it will only consider 1, 2, 3 and 4. It will not consider 5. Let me use 6 here. Now let me run this. You can see that random.sample actually have returned a list. The list contains these 4 elements. Now using the similar logic, I am actually creating a list and assigning the list to items. Let's run this. Let's validate what all values we have in items. Let me say items here. We have 1, 3, 4 and 2. Now if I just run in sequence, in this case I am just running sleep in sequence. It will actually sleep for these many seconds overall. First iteration it will sleep for 1 second. Second iteration it will sleep for 3 seconds. Third iteration it will sleep for 4 seconds. Fourth iteration it will sleep for 2 seconds. So overall it will sleep for 10 seconds. You can validate by running this. You can see that it is sleeping in sequence. once the whole logic is executed, you should be able to see the execution time. It should be close to 10 seconds. You can see 10 seconds here. Now let's see whether we'll be able to speed up the performance by running these things in parallel. To run in parallel, we have to use functions such as map or star map. In this case, I'm going to use map function. Map function takes two arguments. The first argument is nothing but the function itself. So in this case, time.sleep can be passed as first argument. The second argument is nothing but list. Depending upon the number of threads using which pool is configured, which is nothing but 4 in our case, it will try to fork those many threads and it will try to run the sleep function on those many elements in parallel. In this case, items have 4 elements and hence all the 4 sleep functions on those 4 elements will be running in parallel. Let's run this. Also keep in mind that time.sleep will just sleep for those many seconds. It will not return anything. That's why you are seeing nuns here. The overall execution time is nothing but 4 seconds. It is based on the longest amount of time a particular sleep is invoked. We have 4 elements, 1, 3, 4 and 2. One of them is 4. By the time the longest one is done, the rest of the other sleep functions are also executed. That's why you can see the wall time as 4.02 seconds. The output is a list of nuns because time.sleep doesn't return anything. Now let's explore one more thing. In this case, I'm actually creating a list for items between 1 to 25, which means it will actually create a list of 24 elements. Let's run this to create a list of 24 elements. Now let's import math. I have imported math. Now I'm actually invoking a function called as square root on item. This will be fast. It will not take so much of time because we are not sleeping. You can see that it took only 34.1 microseconds. Now let's say items underscore square root. You can see the output here. For each and every element in items, we got the square roots. Let's try map to execute this in parallel. The reason why I'm demonstrating this is because square root will return a value. It is nothing but square root of the given number. Now let's run this. You can see that it just took 16.4 milliseconds compared to little bit more time here. It took 34.1 microseconds. I don't know whether this is small or this is small. Both of them are not very big numbers and hence you can ignore. Let's focus on the data that is written here. Instead of saying nuns, it is actually giving us the square root of the original numbers. Because square root returns a number based upon the argument that is passed to square root, you can actually assign the output of pool.map to a variable like items underscore square root. You should be able to review the output as well. Now let's say items underscore square root. It will work as expected. Now let's say I would like to round off these numbers to 2 decimals. I'm actually creating a new list. Let's review the details about this new list. It contains the element, which is nothing but this one, the square root of the original number, then the number of decimals using which the numbers are supposed to be rounded. So in this case, we have a list of tuples. Each tuple contains the square root of a number and the number of decimals up to which the square root has to be rounded. Now using star map that is there as part of pool, we should be able to use round on top of these elements and we should be able to round off each and every number to 2 decimals. Let's check the definition of star map. It is similar to map, however, the elements of the iterable are also supposed to be iterable. In this case, we have tuples. Tuples are nothing but iterables. Now, automatically, the elements in the iterable will be considered as arguments to this function. Round takes 2 arguments. The first argument is nothing but the decimal number. The second argument is nothing but integer, based on which the decimal numbers are supposed to be rounded off. Now, let's run this. You can see the square roots of the numbers rounded off to 2 decimals. When it comes to star map, we have to pass the function as first argument. The second argument is supposed to be iterable of iterables, whereas with respect to map, the first argument is supposed to be function. The second argument is supposed to be iterable itself. The iterable should contain simple elements. Those elements will be passed as single arguments to the function that is passed as part of the map function here. Make sure you understand this subtle difference between map and star map. Depending upon the nature of the function and the number of arguments it takes, you have to choose between map and star map and then you have to take it further. That being said, now let's go to the details about how to improve the performance of uncompressing the files using multiprocessing, as we have understand some of the nuances related to multiprocessing. At this time, we are going through the details related to multiprocessing. In the previous lecture, we have seen details related to map and star map that are available on top of pool object. Now, let's go to the details about using multiprocessing in a bit realistic scenario. In this case, we'll try to uncompress multiple files in parallel. As we have already uncompressed in the past, I would like to reset my data folder. For that, I'm first deleting the data folder. Once the data folder is deleted, let me run this command, which will take care of creating the folder data in the current folder. Now we should be able to use this command to get all those files which have NYSE prefix and GZ extension. Let me add to this cell. Once this tar command is run, then I should be able to run this to get all those files which have NYSE underscore as prefix and also GZ as extension. Now let me import subprocess and then run this command to get all the compressed files. We should be able to review the compressed files by running this. We see all the compressed files related to NYSE here. Now let's import OS module and run this. In this case, I'm not running using multiprocessing. I'm directly running. Let's see how long it will take to run this in serial fashion. You can see that it took 4.32 seconds. Now let me reset data folder again because the files are already uncompressed. Let me get the details about all the files with NYSE underscore prefix and GZ extension. Now compressed files will have NYSE related compressed files. Let me run this to import multiprocessing as MP. This time I'm actually creating pool with 3. Let me run this to create pool with 3. To invoke the file, we have to use gunzip command. The way you can invoke gunzip command is like this. Using os.system, you should be able to use gunzip like this by passing the file name. Once you use gunzip command like this as part of os.system, the file will be uncompressed for you. Now we have to build a list of these strings so that we can pass it to map or star map. In this case, we can use map because system takes only one argument. When you have to deal with those functions which takes only one argument leveraging multiprocessing, you can use map. That being said, this logic will actually take care of creating gunzip commands for us. Let's run this. Now gunzip underscore commands is of type list. You should be able to review the details of that list by running this. You can see all the gunzip commands here. Now we should be able to leverage these commands which are in list as part of map function by passing as second argument. The first argument is supposed to be os.system. You can see the logic here. Pool.map, os.system, gunzip underscore commands, which is nothing but this list. Now let's run this and see how long it will take. Earlier it took 4.3 seconds. Now it took 1.79 seconds. You can compare with the earlier number. It actually took 4.32 seconds. With 3-degree parallelism, it took 1.79 seconds. You might not get a 3x performance improvement. It all depends upon the variations in the file sizes and a few other things. And hence don't expect the degree of scalability is 3x because we are using 3 parallel threads. It might be somewhere between 1x and 3x. As you use more capacity than the system can handle, it might even be less than 1. That's where specifying appropriate value to pool while building the pool object is very, very important. When it comes to os.system, if the command is successful, it returns 0. That's why you're seeing zeros for all OS system commands here, which means all of them are successful. You can validate by running this command. We should not be seeing any compressed files with NYSE underscore as prefix. If it is returning some results, then it didn't work as expected. If it is not returning anything, then it have worked as expected. You can see that it haven't returned anything. That means it have worked as expected. This is how you should be able to improve the performance using multiprocessing when it comes to dealing with long-running tasks. Multiprocessing is very powerful. Make sure you are comfortable with it. As part of this lecture, let's perform another task from the perspective of automating using Python on top of Linux. In this case, we have several files under data/retail_db with part-5 zeros as the name. We would like to add extensions such as .csv to it. Let's review the files here by using this command. As part of retail.db folder, we have several subfolders. Each of these subfolders have file with this name. I would like to change the names from this name to name with extension .csv. The name will be retained, but the extension will be added. To rename the files, either you can use mv command using subprocess.check call, or you can also use functions such as rename. I'll be using os.rename to take care of renaming the files. The reason why I'm falling back on OS is because the functions that are available on top of OS module will work even on Windows. Let's import OS and also let's check the help on rename. Rename takes two mandatory arguments, source and destination. Using the destination name, it will rename the source file name. Now we should be able to iterate through these files and we should be able to consider renaming these things. Let's go to the logic so that you understand how it can be achieved. To get the files, I'm actually using glob. If you review this logic, I'm actually iterating through all the elements under data retail_db. Then I'm actually checking whether it is a file or not. If it is a file, I'm just printing saying renaming that file name. Others will be ignored. Let's run this. You can see the details here. Keep in mind that the files are not renamed yet because I haven't added the logic yet in this if condition. Now using os.rename, I should be able to rename these items with .csv extension. I'm just capturing the item name and then I'm concatenating .csv to it while invoking os.rename on each and every file. Now let me run this. It will take care of renaming all the files for us. We can validate whether the files are renamed or not using this approach. Now you can see the file names with .csv extension. This is how you should be able to leverage OS module along with the glob to rename the files. You can also use subprocess checkout. However, subprocess checkout with mv command might work only on Linux. It might not work on Windows. Using glob and OS will work both on Linux as well as Windows. You need to make sure you use appropriate functions with appropriate modules depending upon your requirements. I would prefer to use OS and glob as much as I can to take care of automation around file metadata. If you have to perform these type of tasks on Linux and also if you are comfortable with Linux, you can also consider subprocess which contain functions such as check output and check call. Depending upon your requirements and convenience, you can make the choice and you can take care of automating these repetitive tasks leveraging Python as programming language. As we deploy applications on Linux, at times we might have to copy files between the systems. In this lecture, as well as few subsequent lectures, we'll actually talk about automation around copying files between the systems using Python as programming language. To begin with, let's make sure we have required remote instances so that we can explore the details related to copying files between the systems. As we have seen earlier, we can have two EC2 instances like this to simulate as if we have two remote instances. Also, we have our PC already. In this case, I'm going to demonstrate using Ubuntu that is set up on top of Windows. From here, I would like to copy the files onto the remote machines. If you don't have these remote machines, you can actually provision from AWS. I have covered those details as part of the earlier sections. Go to that section and make sure you set up at least two instances so that you can explore all the nuances related to automation around copying the files between the systems. When it comes to my systems, the two instances are nothing but these ones. I can also get the DNS of these two instances by selecting these two. Let's wait until it actually gives us the results. Let me deselect one of them. Under the details, we can see the public IPv4 DNS for this instance. Now let me deselect and let me select this. We should be able to see the public IPv4 DNS for the second instance. We'll be using these two instances which are set up using Ubuntu operating system in AWS to explore all the details related to automation of copying files between the systems. As we have both the instances, let's make sure we can connect to those two instances. These two instances are actually set up using a key pair called as gsdemo. Already I have gsdemo.pem copied onto this machine. I can validate by launching terminal within Jupyter. You can also connect to the terminal directly using SSH based tools such as PowerShell or PuTTY, etc. Now let me say ls-ltr ~/.ssh gsdemo.pem. You can see the details of the file here. Now I should be able to say /i ~/.ssh then gsdemo.pem. The username is nothing but Ubuntu. Then I can actually specify the public IPv4 DNS. I should be able to copy the public IPv4 DNS of the first instance by selecting it and then by clicking on it. Now I should be able to paste here, hit enter. It will take care of connecting to that EC2 instance using Ubuntu as user. Let me exit. I can also actually say hostname -f like this to just connect and run that command and see the output of hostname -f on the remote machine. You can see the output here. Now I should be able to deselect this, select this, copy this. Let's go back to the terminal here. Then say /i ~/.ssh gsdemo.pem. Then Ubuntu @ paste it. Then hostname -f, hit enter. It will take care of connecting to this second instance. Then it will actually get us the private IPv4 based host name. You can see the details here. Both are different. This is how you can actually validate whether you can connect to the remote machines or not. It is very important for you to validate this before getting into the automation using Python as programming language. As we have 2 remote instances, it's time for us to explore how to copy the files onto the remote instances by automating using Python as programming language. As part of this external module, we are going through the details related to automation using Python on Linux. So far, we have gone through the details related to issuing Linux-based commands using Python as programming language using modules such as subprocess, and also interact with Linux file system using modules such as OS, glob, etc. Now, it is time for us to understand how to make sure we can use Python as programming language to talk to remote machines. One of the ways is to use subprocess and issue commands onto the remote machines directly using SH. Another way is using high-level modules such as Fabric. Let's go to the details so that you understand what I'm talking about here. Already we have gone to the details related to subprocess. Let me import subprocess. It have 2 important functions, check_call and check_output. Both can be used to invoke any underlying operating system command. If you are using Linux, you should be able to submit any Linux-based command using subprocess, check_output or check_call. If you want to capture the output, then you have to use check_output. If you just want to run some command and if you are not worried too much about the output, then you should be able to use check_call. In this case, to connect to the remote machine and run commands on the remote machine, if you are using Linux directly, you should be able to use this command as part of the terminal and it will work as expected. Let me use exclamation mark here, paste the command, let me run it. It will connect to the remote machine and you can actually see the output here. Now you can also use check_output like this. It will return the output. You can capture the output and you can take it further. When it comes to check_output, it returns the output in the form of bytes. You should be able to convert it to string and then to list using these additional function calls. You can see the output here. It is nothing but a list of strings. You can give a try with LSF and LTR. You should be able to see the output in the form of list of strings here. On top of this approach, you can also use modules such as Fabric. Fabric is a third-party module. You have to install it to use it. You should be able to use pip install command like this, which will take care of installing Fabric. Either you can kill the Jupyter session, install Fabric and start the Jupyter session, or you should be able to use pip install command like this. As of now, Fabric is already installed on this machine and hence it will just say already satisfied. You can see for almost all the dependencies, it says already satisfied because I have ran this command earlier. Now let me scroll down here. Once Fabric is installed, we should be able to import Fabric like this. You can get help on a important class called as connection. As part of the connection, you can actually pass hostname, username, port number, etc. If you want to specify the key file to take care of logging onto the remote machine using passwordless login, you have to use connect_kw args keyword argument. Let's scroll down. Let's see the example here. You can see that I am passing one of the host DNSs here. The user is nothing but Ubuntu. I should be able to pass the private key file using this approach. In this case, leveraging the key called as key_file name for connect keyword arguments, I am actually passing the private key file name. The private key file name using which we have set up our remote instances is nothing but jsdemo.pem, which is available under .ssh in the home directory of the user that is logged into the underlying Linux system. I am talking about the source system here. Now let me run this. It will take care of creating connection object. Once connection object is created, you should be able to invoke functions such as run. Run can be used to actually pass any command and run on remote machine. In this case, it will connect to the remote machine using these connection details and then run on remote machine. Let's first look at the help on run. It is very straightforward. You just have to pass the command. Also, you should be able to pass some keyword arguments. I haven't explored keyword arguments yet. If you are interested, you can actually explore where keyword arguments comes into play. To run simple commands, it is enough to pass the command itself. Let's scroll down here. Now let's run this to get the hostname of the remote machine to which we are trying to connect and run this command. You should be able to see the private IPv4 DNS details here. It is nothing but the hostname for the remote machine. You can also see the content under /tmp folder on this remote machine using this command. It have connected to the remote machine and it is actually showing the files and folders under /tmp on the remote machine. When we invoke run using connection object, it will actually print the details like this, but the actual object that is returned is nothing but this one. It is of type result. It is not of type byte or anything. Even here you can see the return object details here. Let's run this. Even though you are seeing the output is not added to this variable called as res. Let's check the type of res here. It is of type fabric.runners.result. This res which is of type result have attribute called as stdout. Whatever output you are seeing here will be made available using this attribute. Now let's run this. You should be able to see the details here. Now you should be able to process it and do whatever you want with this output. Let's run this command. Now res will have the result object. I can actually say res.stdout. Whatever is captured as output will be made available using this attribute. It is of type string. You can actually use type on top of it. You will see it is of type string. As it is of type string and as it have new line characters, we should be able to use splitlines function to convert this string to list of strings. Now let's run this. You can actually see the output of this command as list of strings here. This is how you should be able to use Fabric to connect to remote machine and submit commands on the remote machines. Once you get the result from the remote machine, you should be able to process using this approach. This is one of the neat approach which you can use to actually run commands on the remote machines. You should be able to easily automate using Fabric module. On top of this, you can also use this approach. You can actually leverage check output function to invoke any command. The commands can be to issue certain commands on the remote machines. Even this one will actually return the output in bytes type. You should be able to convert it to list of strings using this approach. Either of the approaches will work. Whatever is convenient to you, you can actually follow that, and you should be able to use that approach to run commands on the remote machines. You can also think about automation using either of the approaches. As part of this section module, we are going through the details related to automation using Python on Linux. At this time, we are talking about copying files using Python and SCP. Let's understand how we can actually take care of copying files onto multiple machines in parallel. We'll be using even multiprocessing in this process. First, I am creating a variable by name hosts, which will contain the two remote machines which we have already set up on AWS. Now, hosts is of type list, which contain the details about the two instances. Let me delete the folder data in the home directory of this user. It is not actually in the home directory. It is actually in the current directory. You can see the data folder here. I am first deleting that folder. Let's run this. It will take care of deleting the folder. We can refresh to see whether the folder is deleted or not. Already I have the backup of data in the form of compressed tarball. I should be able to uncompress and untar by using this command. As I am running in this folder where the notebooks are, automatically the tarball will be uncompressed and untarred into this location. It will create a new folder called as data. Let's run this. Let's validate whether folder is created or not. You can see that folder is created successfully. We can also validate by using this command. Let's see what all subfolders we have. We have several subfolders. Out of all these subfolders, we'll be considering only retail.db, retail.db.json, nyc_all, cards. We'll try to copy all these folders in parallel onto both the EC2 instances which we have set up earlier. Now let me run this. It will create list of subfolders under data. Now let me import iter tools as iter. The reason why I'm using iter tools is because I would like to map all these four folders with both the EC2 instances. Iter tools provides a function called as product. Using product, we should be able to create a Cartesian product using these two lists. The two lists which we are talking about are nothing but hosts and folders_tbc. TBC stands for to be copied. You can actually get the syntax of product by using this approach. You should be able to go through the documentation to get the syntax of product. Product take multiple iterables as argument. On top of it, it also take repeat. Don't worry too much about repeat at this time. You can just pass both the iterables here. The first iterable is nothing but hosts. The second iterable is nothing but folders_tbc. Let's run this. You can see the list here. For each and every EC2 instance, we have all the four folders mapped. You should be seeing 8 entities as part of this list. I am creating a variable called as hosts and folders, and I am returning the list to it. Let me run this. Now hosts and folders will contain the 8 entities. Each entity is of type tuple. The first element in the tuple is nothing but EC2 instance. The second element in the tuple is nothing but the folder which is supposed to be copied. Now let's import Fabric. The reason why I'm using Fabric here is to make sure that we have a data folder on both the instances. Under /tmp, I'm going to create data folder. First, I'll be cleaning up the existing data folder. Then I'll be creating the empty folder. In this case, I can actually add one more command, which is nothing but connection.run rm-rf/tmp/data. If you look at the logic here, I am iterating through hosts list, which means it will iterate through this list 2 times. Each time it will actually connect to the remote instance based upon the host that is being iterated at that time, and then it will try to run these 2 commands on that remote machine. First it will remove the data folder, then it will add the data folder. You can also validate by using ls-ltr to see if the data folder is created or not. Let me add one more command here. It is nothing but connection.run ls-ltr. Now let's run this. You can see the output here. However, the output is related to only the last one. It haven't printed the output for each and every ls-ltr command. It is because we are not using print statement here. This is one of the limitations using Jupyter based environment. If you want, you can actually assign the output to a variable and then you can take it further. Let's give a try here. Let's say res equal to, then let's say print res.std out, so that we can actually see the output from both the commands on both the instances. Let's run this. This time we should be able to see the output from both the instances. You can see details here, which means the commands have ran successfully on both the instances. Now we have 8 commands that are supposed to be run. We should be able to use multiprocessing. I'm importing multiprocessing as MP here. I'm creating a pool of 4 threads here so that 4 SCP commands can run in parallel. Now let's review the details in this list. I have copied it. Let me add a new cell here. Let me paste here. Let me say of 0 to see the first entity. You can see the first entry or entity here. It is of type tuple. The tuple contains the host name and then the folder which is supposed to be copied. Now using these details, we have to build SCP command. We can define a function and we should be able to use it. However, with respect to multiprocessing in Jupyter, if you have a function as part of Jupyter notebook itself, it will not work. We need to have an external function. For that purpose, I have created a Python program called as scp_util.py. Let's review the details with respect to scp_util.py. It has a function called as copy. It takes several arguments. The arguments are nothing but host, folder, user, private key, target folder. When it comes to arguments such as user, private key and target folder, we have default values and hence we don't need to pass arguments for these. However, host and folder should be passed. Using the details that are passed to copy, we are going to build command, and then using check_call, we are trying to execute that command. It will take care of executing whatever command that is being built when we invoke copy. Now I'm importing scp_util here. It will expose copy function. As host and folders is of type list of tuples, as we want to pass multiple arguments to copy function, we should be able to take care of using pool with star map like this. The first argument is nothing but the function, which is nothing but scp_util.copy. The second one is nothing but iterable of iterables, which is nothing but hosts and folders. Each tuple will be converted as arguments to copy. Then it will actually try to execute whatever logic is there in that function. Now let me run this. It will take care of copying the files in parallel from the local machine onto the remote machines. We are trying to copy 4 folders recursively onto remote machines. It will take some time. Let's wait until it is executed. Then we will validate whether the target systems have these folders or not. Once again, we should be able to use this logic to actually validate. While it is running, let me copy paste this. In this case, we just have to run ls-ltr on temp folder. Let me delete this. In this case, I should be having /tmp/data. Even earlier also, we should have /tmp/data. There is a bug in this code. We already have data folder on the remote machines in the home directory. That is why it is showing up here. However, the command should be this one. Now let me scroll down. Let's wait until this is executed. Then we'll execute this to make sure whether we have files and folders or not. Instead of using ls-ltr, we can also use find command. Now all the copy commands have ran successfully in parallel because of the pool.star map. You can see that it took 2 minutes 3 seconds. We are seeing all zeros because all check_out calls are successful. If you look at scp_util, we are actually using check_call. We are passing the command which is nothing but scp to copy a particular folder onto specific target machine in this location. Now let's go back here. Let's run this to make sure all the files and folders are recursively copied under /tmp/data folder. We should be able to see the output here. One is related to one of the two instances. Let's scroll down. All these are related to one of the two instances. Then you can see the output related to the second instance. You can also customize the behavior by printing the name of the instance before printing the output. So in this case, we can actually say getting data from so and so instance before printing the standard out. So let me say print running on host Now you can see the details about the instance before printing the output. Once we are done with the first instance, we should be able to see the details with respect to the second instance also. This is how you should be able to leverage the power of Python as programming language to take care of the automation, and also using modules such as multiprocessing, we can improve the throughput of our long-running tasks as well. In this case, we have demonstrated using SCP. Even in other scenarios also, wherever we are trying to run a series of steps, if they can be run in parallel, we should be able to take care of it using multiprocessing. That being said, make sure you understand how you can leverage Python as programming language to interact with remote machines, not only in serial fashion, but also in parallel fashion using modules such as multiprocessing.